Right, so in this video I'm going to have a look at the Junior Cert Higher Level Maths Paper 2 2017, and I'm going to have a look at questions 3 and 4. In question 3, Carey has some ball bearings. Each one is in the shape of a sphere with radius 6 millimeters. So the first question is find the volume of one of these ball bearings. Well, the volume of a sphere is just 4 over 3 pi r cubed. We've got to give our answer in terms of pi, so it's just going to be 4 over 3 pi. We leave pi there. The radius is 6, which we've got a cube. So when you work that out, you get 288 pi. Now we're talking about millimeters cubed. So the volume of one of these, spheres, one of these ball bearings, is 288 pi millimeters cubed. Second part then is Carey is going to melt down some of the ball bearings. She's going to use this material to make a sphere radius 25 millimeters. So she's going to make one big ball bearing. Find the least number of ball bearings Carey must melt down so that she has enough material to make the sphere of radius 25 millimeters. Okay, so the first thing we're going to do is find the volume. The volume of the sphere again is 4 over 3 pi r cubed. So what we're going to do first of all is find the volume of this large final ball bearing that she's going to make when she combines all these small ones. So it's going to be 4 over 3 pi times 25 cubed. 25 is the radius of the large ball bearing that she's going to make. So when you do that, you get 62500 over 3 pi millimeters cubed. Now I've left it as a fraction. You don't have to really, but you could write it as a decimal if you like, but I'll just leave it as a fraction. So this is the volume of the large final ball bearing that she's going to make. So we want to know how many of the small ones will she need to make this. So all we've got to do is divide this volume by the volume of one of the small ball bearings. See how many of those small ball bearings will divide into this large one. So we're going to take 62500 over 3 pi, and we're going to divide it by 288 pi. That's the volume of one of the small ones. Now when you divide these two, the pi's will disappear. You just get 1. When you divide pi by pi, you'll get 1. So divide this fraction here by 288 and you will get 72.3379 and so on. So how many ball bearings will she actually need then? Well, she can't use 0.33 of a ball bearing, so she'll actually need not 72 ball bearings, but the answer, if you like, the answer here will be she'll need 73. She'll need at least 73 ball bearings to make this large ball bearing with radius 25 millimeters. Okay, so that's the first one. Now, the second one. The third part is find the radius of the biggest sphere Carey could make if she had 350 ball bearings. So if she had 350 of these ball bearings, melted them down, what would be the radius of that large ball bearing that she could make? Well, let's find the volume of 350 ball bearings. That's going to be equal to 350 times the volume of one of them, which was 288 pi. So the volume of the large ball bearing is going to be 100800 pi millimeters cubed. So that's the volume of the large ball bearing. We got to find the radius of it. Well, we know that the volume of a sphere is just 4 over 3 pi r cubed. We know the volume of our large sphere. It's 100800 pi. We've got 4 over 3 pi r cubed on this side. Now the only unknown in this particular equation is r, which is what we want to find. Pi is a number, 4 over 3 is a number, pi is a number, 100,800 is also a number. So we have everything here except the r. So we can isolate this r to find our answer. So first thing we can do here is divide both sides by pi. So we end up with 100800 is equal to 4 over 3 r cubed. Next thing we can do here is just divide both sides by 4 over 3. If you divide by 4 over 3, it's the same as multiplying by 3 over 4. And that will give me my r cubed. So r cubed then is going to be equal to 75600. So that means r then is going to be equal to, the opposite to cubing here is cube root. So you've got 75600 here, and we've got to get the cubed root of it. So that gives me a value for r of 42.283 millimeters. We were required to give our answer correct to the nearest millimeter. So r here is going to be equal to just 42 millimeters. So this is to the nearest millimeter. Okay, so that's that part of the question done. In fact, that's question 3 finished. Let's move on to question 4. Question 4 here involves this stem and leaf diagram here, and we can see immediately that there's one number missing here. They put in p here instead of this number here, so this is going to be 40 something or other. But let's have a read of the question anyway. We have a stem and leaf diagram, and it shows the number of copies of a newspaper called the Newry News sold each week over 17 weeks. So there are 17 numbers here. The value in the diagram of one of the weeks is p, and p is a natural number. It's going to be some number between 1 and 10, not including 10. So it's going to be a single digit number here. Now 3 line 2 here means 32 copies of the Newry Press. So they're just telling you what the key actually mean, what the numbers actually mean here. So this number here is actually 32. This number here is 34, and so on. The range of the data is 39. In other words, if we take the largest number, subtract the smallest number, we get 39. We've got to find the value for p. Well, our largest number is 40 something or other. It's going to be 40 plus some number p. Because if you think about it, this 43 here is going to be 40 plus a 3. This here is going to be 40 plus a 1. This 21 here is going to be a 20 plus a 1, and so on. So this number here is actually 40 plus some single digit number called p. Now we got to subtract 8. 8 is the smallest number. That'll give us our range, and we're told the range is 39. So what we get here is 40 plus p minus 8 equal to 39. That will give me 40 minus 8, which is 32 plus p equal to 39. So subtract 32 from both sides. That will give you p is equal to 7. So this number here is actually 47. Represents 47. Okay, so that's p. Find the value of each of the following statistics in the data. So the first one we have to find is the mode. The mode is the number that occurs most often, and we can see here that the number that occurs most often is 19. We've got 3 19s here, and there isn't another number here that occurs more than 3 times. So our mode here is just simply 19 newspapers. The next one we have to find is the median. Now the median is the middle number. So in order to find a median, you've got to put the numbers in order. Now happily enough, for a stem and leaf diagram, they're already in order. We have the smallest number here, which is 8, the largest number here, which is 47. So you've got to find the middle number. Now the middle number is going to be easy enough to find here because we have 17 numbers. And 17 numbers is an odd number. So whenever you've got an odd number, there is going to be a number in the data that is a median. So I know that it's going to be this number here, 21. Because if you look at it, you've got 1, 2, 3, 4, 5, 6, 7, 8 numbers to the left of it. And you've got 1, 2, 3, 4, 5, 6, 7, 8 numbers to the right of it. So 21 is our median. It's the middle number. So I can write in the median is going to be 21 newspapers. Okay, so next one then, the sum of the data in the stem and leaf diagram is 431. In other words, if you add up all the numbers in the stem and leaf diagram, you get 431. Use this fact to find the mean of the data correct to one decimal place. Well, the mean of the data is just what you get when you add them all up, divided by the number of numbers. Well, what you get when you add them all up, we're told in the question, is 431. The number of numbers is 17, so it's just simply 431 divided by 17, and that gives you 25.3529 and so on. We're asked to find our answer correct to one decimal place, so that's going to be equal to 25.4 newspapers to one decimal place. Right, the next one then, part D. Okay, now they add an extra week here. They're saying in the 18th week there was a special issue of the Newry News, and there were a lot more copies of it sold than any of the other weeks. In other words, if we go back to our stem and leaf diagram, the largest number of newspapers that were sold here was 47, but they're saying there was another week, an 18th week, so there's another number here or even further down that's bigger than all of these numbers. And they're not telling us what that is, not yet anyway. So first thing we were asked to find is the modal number of copies sold per week over the whole 18 weeks. In other words, we've got to find the mode of this data. Well, if there was another number added on here somewhere and it's not the same as any of these, well then the mode is still going to be 19. 19 is still the largest number of newspapers sold. Or sorry, not the largest number of newspapers, but it's the number of newspapers that was sold most often, if you like, 3 times. They sold 19 newspapers 3 times. And it doesn't matter if there's another number up here. If there were 1 million newspapers sold, it's not going to affect the mode. So 19 is still going to be our modal value here. So we have 19 newspapers here. Find a median number of copies sold per week over the whole 18 weeks. Now in this particular case we have 18 numbers, so we have an even number of numbers. So when there's an even number of numbers, there are going to be 2 middle numbers, if you like. So if we take 18 number, there are 18 numbers in total, divide by 2, we get 9. Now what we do is we pick the 9th number and we pick the 10th number. We add those 2 numbers and divide by 2. So let's find the 9th and 10th numbers. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So our 9th number is 21. Our 10th number is 25. So we're going to use 21 and 25. 21 and 25. So we're going to take 21 plus 25. We're going to get the mean of these 2 numbers. We're going to get the mean of those 2 numbers. What you get when you get the mean of those 2 numbers, 21 and 25, is 23. So 23 is equal to the median over 18 weeks. Because it doesn't matter that we don't know how many papers were sold on the 18th week. The procedure doesn't change. That number is not going to affect the median, or the way you calculate the median anyway. Okay, so let's have a look then at the last part of this question, and it talks about the mean number of copies sold per week over the whole 18 weeks is 28.5. Work out the number of copies that were sold on the 18th week. Okay, so the mean is just going to be what you get when you add up all the numbers and divide by 18. So we're going to be dividing something by 18. Now I'm going to say let x equal the number of newspapers sold on during the 18th week. So really what I've got to do is take that number x and add it to all the other numbers, all these other numbers here. We know that there's some number x here, we don't know what it is. We've got to add it to all of these other numbers and divide by 18. However, we are told here in this part of the question that the sum of the data in the stem and leaf diagram is 431. So in other words, when you add all these up, you get 431. So it's already done for us, really. So what we need to do here is add that 431 to the number of newspapers sold on the 18th week, divide by 18, and that gives us our mean. So in other words, this x plus 431 divided by 18 should give us our 28.5. So we've just got to work this out, solve for x, because there's only one unknown in this equation, so we can isolate that unknown. So the first thing I'm going to do here is multiply both sides by 18. So if I multiply the left hand side by 18, I get 513. Multiply the right hand side by 18, it'll just cancel, or you'll just get 1 really, plus 431 here, x plus 431. So all I've got to do now is subtract 431 from both sides, and that will give me 82. So in fact there were 82 newspapers sold during the 18th week. So on the stem and leaf diagram then, that would be way down here. There would be there would be a big gap here between 47 and 82. So that is it, I think, for this question. Yeah, there isn't anything else, so that's it.